Welcome back to Max with RP. In the earlier video, we had done some very simple problems as an introduction to three-dimensional geometry. Today we are going to do problems involving straight lines. What are skew lines? Skew lines are lines which are neither parallel nor intersecting. So if you have two lines going like this, one line like this, one line like this, they are called skew lines. So what will be the line of shortest distance between them? It is the line which is perpendicular to both the lines. So if I talk about shortest distance, it is the perpendicular distance between both the lines. So if you take any two lines, either they are intersecting, they are parallel, or we can always find the shortest distance between them. Now let us look at this following example. There are two given lines, r vector equal to (4i minus j plus lambda times I plus 2j minus 3k) and r vector equal to I minus j plus 2k plus mu times 2i plus 4j minus 5k. We know that the vector form of the equation of any straight line is r vector equal to a vector plus lambda times b vector. Now, we'll consider the first line as r vector equal to a1 vector plus lambda times b1 vector. So, a1 vector equal to 4i minus j. a2 vector is this, a point on the second line, which is I minus j plus 2k. b1 vector is this, which is the direction of the first line. The drs of the first line are given by I plus 2j minus 3k. b2 vector equal to 2i plus 4j minus 5k. Now you can first look at the straight lines. You can if they are parallel, then the drs will be the same. You can see that the drs of the first line is given by 1, 2, minus 3. Second line is given by 2, 4, minus 5. Therefore, they are not parallel. Then the shortest distance is given by a2 minus a1 dot b1 cross b2 by modulus of b1 cross b2. Since it's a distance, we take always the absolute value. So let us first find a2 minus a1. a2 minus a1 is given by this minus this. I minus 4i is minus 3i minus j minus of minus j. Minus j plus j will be 0 plus 2k. What is a2 minus a1? I minus 4i, which is minus 3i, minus j minus of minus plus j, which is 0j, plus 2k minus 0k, which is plus 2k. Okay. Now, how to find the cross product of b1 and b2? We have to take the determinant. So, b1 cross b2 will be the determinant ijk 1, 2, minus 3, 1, 2, minus 3, 2, 4, minus 5, 2, 4, minus 5. You can check with the question also, 1, 2, minus 3, 2, 4, minus 5. Okay. So, we have to find b1 cross b2. How will you find the determinant? I into, leave out that column and leave out that row, you will get minus 10, minus of minus plus 12. Minus j into, leave out that column and row, you will get minus 5, minus of minus 6. Leave out that column and row, minus 5, 1 into minus 5 is minus 5, minus of minus 6, so plus 6, plus k times, leave out that column and row, 4 minus, this is 4, minus 4, which is 0. So this is 2i. What is the 6 minus 5 is 1. So minus j plus 0k. So I into minus 10 plus 12, which is the component of I, minus j into minus 5 plus 6 plus k into, leave out the column and row, 4 minus 4, 0. So 2i minus j is b1 cross b2. Now what is modulus of b1 cross b2? Will be root of 4 plus 1, 5. Root of 2 square plus 1 square, which is 5. Okay. Now a2 minus, so therefore the shortest distance will be, this is the formula, a2 minus a1, which is minus 3i plus 2k dot b1 cross b2, which is 2i minus j by root 5. This will be minus 3 into plus 2 is minus 6. J plus j component is 0 plus k component is 0. So minus 6 by root 5. Since it is distance, 6 by root 5 units. So the shortest distance between the two given lines is given by 6 by square root of 5 units. What is the formula we use? a2 minus a1 dot b1 cross b2 by modulus of b1 cross b2. What is the vector equation of any straight line? R vector equal to a vector plus lambda times b vector. Now look at another set of straight lines for which we are going to find the distance. So here what do you observe? The drs are one and the same. So the straight lines are parallel. If the lines are parallel, then how do you find the shortest distance? Is given by b vector a2 minus a1 cross b vector by modulus of b vector. You will always take the absolute value. Now b vector is what? Is the it is the direction of both the straight lines. That is, b vector is equal to 2i plus 3j plus 6k. In this case, the drs are exactly the same. Sometimes they can be proportional. But since they are ratios, they can always be simplified, and you will find that even if they are proportional, they represent the same drs, because you can cancel the common factor. So b vector is given by 2i plus 3j plus 6k. What is a2 minus a1? Now a2 minus a1 is given by, before that, what is a1 vector? A1 vector is I plus 2j minus 4k. This is your a1 vector. What is a2 vector? A2 vector is 3i plus 3j minus 5k. So a1 is I plus 2j minus 4k. A2 is 3i plus 3j minus 5k. So what is a2 minus a1? 3i minus I, which is 2i, plus 3j minus 2j, which is plus j, minus 5k plus 4k will give you minus k. A2 minus a1 is, again I am repeating, 3i minus I, which is 2i, 3j minus 2j, which is j, minus 5k plus 4k, which is minus k. So a2 minus a1 is given by 2i plus j minus k. So what is it that we have to do to find the shortest distance? Is a2 2i plus j minus k cross b vector. What is b vector here? 2i plus 3j plus 6k by modulus of b vector. What is modulus of b vector? Root of 4 plus 9 plus 36. Okay. Now how to find the cross product of that? I, J, K, 2, 1, minus 1. That is A2 minus A1 is what? 2, 1 and minus 1. The DRs are 2, 1 and minus 1. Then we have to find the cross product with B vector. What is B vector? 2, 3 and 6, which is I into leave out that column and row. You will get 6 minus of minus. Leave out that column and row. 6 minus of minus 3, which is 9. Minus j into, leave out that column and row, you will get 12 minus of minus 2, which is 14, plus k into, leave out that column and row, 6 minus 2, 4. So, which is 9i minus 14j plus 4k is the cross product. So, I into 6 plus 3, which is 9, minus j into, leave out the middle column and row, you will get 12 plus 2, which is 14, plus k into 6 minus 2, which is 4. But I told you, you should always take the absolute value. Okay. The denominator we have 7. So what is the numerator? So shortest distance will be square root of 81 plus 196 plus 16 by 7. So you have 196, 81, which is 277 plus 16. So this is equal to root of 293 by 7 units. So the distance between the parallel lines is given by A2 minus A1 cross B vector by modulus of B vector, which simplifies to root of 293 by 7. So if the lines are parallel, the distance between them is given by A2 minus A1 cross B vector by modulus of B vector. Let's pass on to the next problem. We are going to find the coordinates of the foot of a perpendicular from a given point to a line. So you have a point PA whose coordinates are given by A minus 1, 8, 4. It's too thick. To the line joining B and C, 0, minus 1, 3, which is B, and C whose coordinates are given by 2, minus 3, minus 1. Let P be the foot of the perpendicular and later on let Q be the image. If Q is an image, P is the midpoint of AQ. So our first step is to find the coordinates of P. Let us first write down equation of BC. Now equation of BC in 2-point form is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. So using that, equation of BC will be x minus x1, which is 0, x2 minus x1 is 2, equal to y plus 1 by minus 3 plus 1, which is minus 2, equal to z minus 3 by minus 1 minus 3, which is minus 4. But this I can 2 minus 2 minus 4, I can write it as 1 minus 1 minus 2. So these are the DRs of BC. Okay. Therefore, now this line I can equate it to some lambda. Okay. Now they determine any point on BC. What do you mean by equation? Any point on the line can be determined from the equation. So in terms of lambda. So for some lambda, P will be, for some lambda, P will be what? If I equate this to lambda, 2 lambda minus 2 lambda minus 1, minus 2 lambda minus 1, minus 4 lambda plus 3. This is minus 4 into lambda plus 3. So what will be the DRs of AP? Because we are going to use the fact that AP vector dot BC vector is 0. AP is perpendicular to BC. So AP vector dot BC vector is 0. The product of the drs will be 0. Okay. So what will be drs of AP? Will be, this is what? Minus 184. Minus 184. X2 minus X1. Y2 minus Y1. Z2 minus Z1. So 2 lambda plus 1. Then minus 2 lambda minus 1 minus 8, which is minus 2 lambda minus 9, comma, minus 4 lambda plus 3 minus 4, minus 4 lambda minus 1. Drs of AP are given by x2 minus x1. So 2 lambda plus 1. Minus 2 lambda minus 1 minus 8. So minus 2 lambda minus 9. Minus 4 lambda plus 3 minus 4. So minus 4 lambda minus 1. Now AP vector dot BC vector equal to 0. Therefore, the product of the drs will be 0. What will be the product of the drs? I have already written the drs of BC. Drs of BC is given by 1 minus 1 minus 1, 1 minus 1 minus 2. Okay, so 1 into 2 lambda plus 1. Then minus 1 into minus 2 lambda minus 9. Minus 2 into minus 4 lambda minus 1 equal to 0. This is 2 lambda. This is again 2 lambda. This is again 8 lambda. 2 lambda. This is minus 4 lambda plus 3. See, minus 4 lambda plus 3. I subtracted, from that I have subtracted 4. So I will get minus 1. That's how you got this minus 1. Now the drs are 1 minus 1 minus 2. So minus 2 into minus 4 lambda minus 1 equal to 0. So this is 2 lambda plus 2 lambda plus 8 lambda plus 1 plus 9 plus 2 equal to 0. 12 lambda plus 12 equal to 0. So lambda equal to minus 1. 12 lambda equal to minus 12 lambda. See, 2 lambda plus 2 lambda plus 8 lambda plus 1 plus 9 plus 2. So 12 lambda plus 9 plus 10 plus 2 is 12 is equal to 0, which means lambda is minus 1. So what will be the coordinates of P? P will be, what is P? 2 lambda. So minus 2, minus 2 lambda minus 1. Minus 2 into minus 1 minus 1. Minus 4 into minus 1 is plus 4 plus 3. This is minus 2. Minus 2 minus 1 is minus 3 and 7. Minus 2. This is 2 minus 1 is 1. Sorry. Then 4 plus 3 is 7. Minus 4 into minus 1 is 4. Where am I substituting for the coordinates of P? P is given by minus 4 lambda plus 3. So minus 4 into minus 1 is plus 4. 4 plus 3 is 7. Okay, so P is 217. What is Q? Let Q be A, B, C. Okay. Now, I am removing this for want of space. Now, this is P is the midpoint of P is the midpoint of AQ. So A minus 1 by 2, x2 plus x1 by 2 is the x coordinate of P. So A minus 1 by 2 is 2. So A equal to 5. A minus 1 by 2 is the x coordinate of P, which is 2. So A equal to 4 plus 1, 5. Similarly, B plus 8 by 2 will be 1. So B will be 2 minus 8, which is minus 6. Now, similarly, C plus 4 by 2 will be equal to c plus 4 by 2 is the z coordinate, which is 7. So c equal to 14 minus 4, which is 10. So the image is given by 1, minus 6, comma 10. Are you able to follow? The coordinates of the image is given by 1, minus 6, 10. So today we discussed three problems, where in the first case we found the shortest distance between two lines. Second case, the shortest distance between two parallel lines in particular. Third problem, how to find the coordinates of the foot of the perpendicular from a given point, and also to find the coordinates of the image. What do you mean by image? Q is called the image of A. If BC acts as a mirror, it reflects A such that AP equal to PQ, or P is the midpoint of AQ. So we have used the midpoint formula to find the image after obtaining the coordinates of the foot of the perpendicular. So I hope you understood these three problems. We'll discuss more problems in the next video. Until then, it's goodbye.